Welcome to your review of rate of change, the third standard of the year. We're racing right through the review. After today, we'll have two more standards to review. We might take 2 days on this one because this was the lowest test score on average, and it is a little bit tricky. All right, so let's just start off with basic input-output table, basic table, except this doesn't look basic. First of all, the way I've always done it is I do X, Y, going straight up and down. That's probably what you're more used to seeing, something that looks like this. Well, it could go straight up and down, it could go straight across, it doesn't matter. Another thing you might notice is different is that this doesn't have an X and a Y, it has a D and an L of D. What is that supposed to mean? Let me tell you, whenever you see a letter with a parenthesis like that, that's f of x. That's a function. And remember, with functions, f of x is the same thing as y. So when you see a letter with a parenthesis and another letter, that's your y column. So this is the y column, this is the x column. You might be asking yourself, why do they have to make it so confusing and put all these letters in there that mean nothing to me? Well, they're actually trying to make it less confusing for you. Because the story here is that the rate of change is about lemonade sold per day when you make up your little stand on the corner road and trying to sell lemonade to everybody in the neighborhood. So it's a function of days. It's how many lemonades did you sell per day. So it's L of D. So they're using L and D instead of X and Y, thinking that it makes more sense. L goes with lemonade and D goes with day. And this is lemonades per day, and this is days. It's a function of days. How many lemonades per day? So if you look at it like that, it's actually less confusing than just Y and X, because Y and X could be anything. But these are specific letters. But remember, rate of change is always Y over X. So in this case, it's going to be L of D over D. Right? As long as you can understand that, then you should be all right as far as being up to speed on what we've done with rate of change so far this year, because this is nothing different. It's just in a little bit of a different format. The table's going across, and they're using function notation instead of X and Y. All right. Now let's get down to actually finding some rates of change. When you ask for rate of change, it's pretty much always asked in terms of X. Sometimes you'll see the word intervals. And an interval is just a time period from when to when. All right, so let me just put this into an example here. Let's take the rate of change of lemonade sold from the interval of 2 to 5 days. What's the average rate of change from 2 to 5 days? Well, a lot of people are going to look at this and say 2 days was 96 and 5 days was 296. So how many lemonades were sold from that time? You would subtract 290 minus 96 and you would get 194. And people are going to say that 194, that's my answer. I sold 194 cups of lemonades from day 2 to day 5. Well, that's true. You may have sold 194 cups of lemonades and think that you're rich, but that's not the answer to the problem. That's not the rate of change because it's not a fraction. You got to have Y over X, L of D over D. So it's 194 cups sold total, but not for one day. This is not 194 over 1. This is 194 over 3. That over the course of 3 days, from 2 to 5, because that's what the interval is from 2 to 5. So you look, how did you get from 2 to 5? You added 3 plus 3. How did you get from 196 to 290? You added 194 plus 194. That's your fraction. That's rate of change, a fraction. The y column over the x column, the function over the variable. So it's 194 over 3 is your rate of change, And then you try and reduce that. If it reduces, this does not reduce, so you can just leave it as 194 over 4. Remember how to tell if 3 goes into something. How did I do that so quickly? You add up these digits in the number. 1 plus 9 plus 4 is equal to 14. Does 3 go into 14? No, so 3 does not go into that number. That's how you can check with 3 if it reduces. So from 2 to 5, the average rate of change is 194 over 3. Let's do another one before I go on to the next type of rate of change formats. Let's say the interval is from 1 to 3 days. 1 to 3 days. All right, from 1 to 3 days, that's the matter of 2 days. From 1 to 3 is plus 2. You guys can do that math. This math is a little bit trickier. What do you add to 48 to get to 168? 120. So your rate of change is 120 over 2, and that does reduce real nicely to 60 over 1. 60 cups of lemonade per day is what you averaged for those 2 days. Now, it's just an average. You sold 48 the first day, and then you sold 72 the next day. So you didn't sell 60 in either day. But 60 is the answer, 60 per day, because it's the average rate of change. You sold 120 total over the course of 2 days. That's 60 per day. Even though it was 48 and 72, those two numbers add up to 120. 72 plus 48 is 120. So you sold 120 cups over those 2 days. That's an average of 60 per day. So you got to remember it's an average. You don't really even have to think in the terms of average. If you're getting your denominator and your numerator correct, if you're getting these two numbers, the 2 and the 120 correct, it's going to reduce to 60 over 1, and you're finding an average without maybe even realizing it. But that's how rate of change works. Average rate of change. All right, let me show you how it could look a little bit different than that. It could look like a graph. Now, if you have a graph like this one with a straight line in it, now the rate of change is constant, and that's why we call it slope. So you've always probably heard that slope and rate of change are the same thing. That's true if the rate of change is constant. What do I mean by constant? The rate of change in this problem was not constant. You sold 48 cups, and then you sold 72. That's not a constant rate of change. It's different every day. You went from 48 to 72. If you were to graph that, it would not be a straight line because it's not the same every day. It's not a constant rate of change. To be a straight line, it has to be constant. It has to be the same every day or every interval. And that's what we have here. It's a straight line, so every 4 days it's going up by the same amount. Right? So what is the rate of change on this from 0 to 16 days? Well, your x, like I said, your x column, or in this case your x-axis, is the intervals. That's your denominator. And it's from 0 to 16. So we want to know all the way from here to here. What was your rate of change? And I just drew these little dotted lines in there so you can tell exactly where that point is. Sometimes it's hard to tell. Is that point above the 16, or where exactly is that point? So I drew the little dotted lines just so you know. And on a test, it'll be on graph paper. So it'll be real easy to tell where it's at. So that's another reason I draw it on there, is because this isn't graph paper. All right, from 0 to 16 days, you went from where on your y-axis? Well, we know that we added 16. From 0 to 16 is plus 16. That'd be like if you had an XY table. 0 to 16, your x column is plus 16. Well, what's your y column during that time period? A lot of people are going to say 600. They're going to use 600 over 16, and that's going to be wrong, so don't do that. Why is it not 600? Because where was it when you were at 0? You weren't at 0. What's your starting point on this? What's your y-intercept? 200. So at 0, you're at 200. At 16, yes, you are at 600, but what are you adding during that interval of time? From 0 to 16, you're adding 400. So 400 is your denominator there. I'm sorry, your numerator. So it's 400 over 16, not 600 over 16. All right, if the line looked like this, then it would be 600 over 16 because at 0 you'd be at 0, so you'd be increasing 600. All right, if you don't like the chart, when it's a constant rate of change, when it's a line, it's the same exact way as finding slope from one point to the next. How far up and how far over? How far up do you have to go from this point to get up to that point? You got to go all the way up to here. 4 spaces, and every space is 100. So you went up 400, and how far over did you go? You went over from 0 to 16. You went over 16 spaces, 400 over 16. When it's a constant rate of change, when it's a line, you can figure it the same way you would figure slope, and we've been doing that for the last couple standards, so that should be pretty fresh in your mind. So go ahead and use that on a graph. If it's a straight line graph, in fact, you might have this exact same problem that doesn't even say the words rate of change in there. It just says, what's the slope of that line? And you're going to say 400 over 16. You can do the exact same thing with rate of change. If it's a straight line, slope and rate of change are the same thing. All right, let me show you one more way. And it's not really new. It's a table going straight across like that first one. But they really try and make it tricky in the X column. So like that first one, it's not X and Y. It's H, which stands for hours. And it's W per hour, words per hour. What is the average rate of change in words per hour? And what that means is you people on your phones texting each other. How many words per hour do you text each other? And it starts at 1:30, which is when school ends. So that's when you all start texting each other. That's why at 0 hours, what does that mean? That doesn't say 1:30. It says 0. Well, because 1:30 is your starting point. So you're starting at 1:30 and you're going in terms of hours. So 0.5 hour, that's a half hour. 0.5 is a half. Half an hour is 30 minutes. So if this is one, if you're starting at 1:30, 0.5, that's 2 o'clock, that's 2:30, that's 3 o'clock, and that's 3:30. And finally, it goes all the way till 4 o'clock, which is 2.5 hours after your starting point, which is 1:30. 1:30 plus 2.5 hours is 4 o'clock, so that's right. So on a problem like that, when they're giving you, when the X's don't seem to match up to the story, then I don't see any of these numbers in the story. I see times. You got to convert it yourself. 0 is the starting point. 1:30 is the starting point. So that's 1:30. So that's the tricky part on this one. So you got to be careful on that. All right. So they want to know from when to when. They want to know the rate of change from 2 p.m. to 3:30. So 2 p.m. is at 1. 3:30 is at, I'm sorry, 2 p.m. is at 0.5, my bad. Yeah, 2 p.m. is at 0.5. 3:30 is at 2. Here's another place that you could get messed up. Don't use 130 or an hour and a half. Use the numbers that they give you in the X column and the H column. Use the 0.5 and use the 2. You're just putting these in there so you know which ones to use. Like, you got to use these numbers for your denominator, but which ones? Which one do I use for 2 and which one do I use for 3:30? Well, now you know because you labeled them. So you use 0.5 and you use 2. So how much did you add to get from 0.5 to 2? You added 1.5, 1.5. Everybody can do that math. How about in the Y column from that time? You went from 6, because by 6 at first you're just texting, hey, I'm out of school, and then all of a sudden you get crazy and you just text all day when you get home. So from 6 to 606, that's 600 words you texted in an hour and a half, which I know is probably not near as much as you actually do, but we'll just go with that for this problem. So 600 over 1.5, 600 over 1.5, and that does reduce, and it reduces, I think, into 400 over 1. Yes, it does. So that means you're averaging, during that hour and a half, you're averaging 400 words an hour. So try not to burn up your fingers.